We are discussing about GATE 1987 and this question is related to electronics. The pinch-off voltage for an N-channel JFET is 4 volts. Then pinch-off occurs for VDS when VGS is equal to minus 1 volts is A 3 volts, B 5 volts, C 4 volts, D 1 volt. Okay. We know that this is a symbol for the N-channel JFET, which will be consisting of 3 important terminals: drain, source, and it is gate. And we know that for N channel, gate source junction is always must be, that is for FET, gate source junction must always be reverse biased to achieve high input impedance. So for N channel, drain is of N type and source is of N type, gate is of P plus type. So for that we will apply a voltage like this. So for P side we will apply negative voltage, and for source side we will apply the positive terminal, so that this voltage VGS is always negative, or at most it may be 0, so that the junction may be under reverse bias or may be under open circuit. It should not become forward bias. If it is becoming forward bias, the advantage of JFET having high input impedance will be ruined. So we should not connect positive gate voltage for the N channel JFET and negative gate voltage for the P channel JFET. Okay. Next, now if you are going to be applying a drain to source voltage like this, VDS, so current flows from positive to negative, so a drain current flows in this way, ID. So now we will draw the output characteristics. From that we will say what is meant by pinch off and when it occurs. Okay, and let us assume this is going to be the JFET constructional view. Constructional view is nothing but this is, okay, we'll go again. Constructional view, I will start over here. So this is JFET construction. JFET, N-channel JFET will be fabricated into N-type semiconductor, and into that two P plus junctions are going to be placed. So these two P plus junctions are internally connected. Okay, so we are going to be applying only voltage across one side, which is going to be equally valid for applying voltage for the other side also, because they are internally related, internally connected. So this terminal is going to be kept out and it is called as drain, and for this semiconductor above is drain, this is source, gate, source, drain. These are the 3 terminals. Okay, so at most if you want to get more and more current, VGS has to be 0. Otherwise what happens, as you are making gate source junction reverse bias, at that time potential barrier across this P plus N junction is going to be increases, and since N side is going to be lightly doped, at that time potential barrier penetrates more into channel side. Okay, so by that time the effective width of channel is going to be gets reduced. So to get more current we should have the more channel width. For that what we are doing is nothing but, initially we assume that gate and source are going to be shorted. That implies nothing but VGS is equal to 0 volts we apply. VGS is equal to 0 volts. Whenever VGS is going to be 0 volts, at that time the distance between the region between two P plus junctions is maximum. That is going to be generally treated as 2A, which is maximum, so that a maximum current flows from drain to source, as there is a chance for the maximum width. Now if you apply a drain to source voltage like this, now if you apply drain to source voltage as VDS, increasing from 0 onwards, by that time initially as VDS increases, current increases. So these are going to be treated as characteristics, drain characteristics. Drain characteristics are nothing but it is VDS versus ID. Okay, and initially the current is going to be increases. Initially the current increases up to some value, and afterwards it becomes constant. So this is whenever VGS is equal to at 0 volts. Okay, so this point is going to be treated as pinch off point or pinch off voltage VP, Pinchoff voltage. In this case it was given as 4 volts. Okay, now if you are going with VGS is going to be increases negatively whenever VGS is equal to minus 1 volt. By that time what happens? Okay, whenever VGS is equal to minus 1 volt, now we are going to be applying a voltage as minus 1 volt, that is sorry, this is minus 1 volt minus plus VGS of minus 1 volt we are applying. Okay, so by that time this gate source junction becomes reverse bias. Since gate is heavily doped, okay, the depletion layer is going to be penetrated more into lightly doped, that is channel side. So, and if you neglect the depletion region in P plus side, this will become like this. The channel will be looks like in this way. So this is what the channel now it becomes looks like. Okay, so now the width of channel is going to reduces and it is function of distance, so this will be treated as 2b. okay, this is going to be called as 2b. So the width of channel is going to be reducing, so that now the current producing, even though you are applying the same voltage, is going to be now reduces, so that here the current is going to be reduces and the pinch off is going to be occurs for lesser drain voltages itself. Now the pinch off is going to be appearing across this point. So now we are going to be getting the relation between pinch off voltage and the value of VDS at which the pinch off is going to be occurring, that is constant current you are getting, VDS, VP and VGS. Okay, so if you observe, okay, previously what we have applied is VGS is equal to 0 volts. By that time let us assume 4 volts of VDS you applied such that the current becomes constant. Okay, now this 4 volts of voltage is going to be making reverse bias for this VGS or not, reverse bias for this gate drain junction or not. If you are looking at gate and drain, this is of P plus and it is of N side. Since you are applying more positive voltage to drain, at that time N side is more positive than P side, so that compared to this gate drain junction, it is nothing but simply it looks like a PN junction and it is under reverse bias. So the amount of reverse bias is going to be such that 4 volts reverse bias is making 4 volts reverse bias. 4 volts reverse bias is getting pinch off condition. 4 volts reverse bias is getting pinch off condition when reverse bias gets pinch off when VGS is equal to 0 volts. When VGS is equal to 0 volts. Now if VGS is equal to minus 1 volt, now whenever you are applying minus 1 volt, are you going to apply the reverse bias for the same junction or not? Gate and drain, gate is connected to negative terminal, drain is if you are not applying any voltage. By that time gate is connected to minus 1 volt, drain is connected to 0 volts. Let us assume you are not applying any voltage. By that time for that junction already you applied minus 1 volt reverse bias. To get the pinch off condition we require 4 volts reverse bias, but already 1 volt reverse bias is applied. Okay, so whenever 1 volt reverse bias is already applied through gate, and how much reverse bias voltage it requires extra across drain such that to get the pinch off condition, that is what extra 3 volts reverse bias is sufficient. If you apply VDS as 3 volts, by that time itself 3 volts reverse bias because of drain and 1 volt reverse bias because of gate, both will become 4 volts reverse bias. That is what the required condition to get the pinch off region. So now VDS can be treated as 3 volts only. Okay, so the answer for this one is nothing but A, 3 volts. We can get the relation as like this: VP pinch off voltage is equal to VGS plus VDS saturation. VDS saturation is nothing but at which the drain current becomes saturated, that is becomes constant. So this is the minimum possible, so we can write it as VDS minimum. The minimum amount of VDS required to get that saturation condition, to get the constant current, is nothing but VP minus VGS. Okay, and in this case, if you are saying VGS, only you should go for the magnitude only. So VP is 4 volts and VGS is nothing but 1 volt. 4 minus 1 is nothing but 4 minus 1, that is nothing but 3 volts. 3 volts reverse bias is going to be the minimum drain to source voltage at which pinch off occurs. You can apply more also, but nothing happens, the same situation remains. Okay, so this is a starting point. At this point what we require is 3 volts. So the pinch off voltage for an n-channel JFET is 4 volts. Then pinch off occurs for VDS when VGS is equal to minus 1 volt is 3 volts. Answer is 3 volts. Thank you.